Welcome to Blue Glasses Math. In this podcast, we will explore how our self-perception as math teachers and learners influences our approach to life. Whether you identify as a math enthusiast or not, this podcast is for you. Are you a teacher, a parent, a school administrator, or a student? Join me as we shift our perspective on what it means to be a math person. Let's take a look. Welcome, Pam Harris, to the podcast. Today is Pam² Day, and I am so thrilled to have you here to have a conversation on Blue Glasses Math. Thank you so much for giving me the time. So welcome.
I'm honored to be here. Thanks for having me.
Yeah, for sure. So you and I met live and in person over in New Jersey back in, I think it was like April or May, and it doesn't matter. And you were just so gracious about, yeah, sure, I'll be on your podcast and have this conversation. And I'm like, what better thing to call it is Pam². So here we are.
I don't meet that many Pams anymore.
I know.
Yeah, I grew up with a couple. There were three of us in our church group, and it was a little irritating, actually. I was kind of glad to get out in the world where it was just me. But now I'm glad to find a fellow Pam in math education. How cool is that?
Which is crazy. And you know what? I will say that on the pre-podcast prep, I do use AI, ChatGPT, to kind of like give me some, suggestions. And it came up with something about like a talk about Pam's such and such Substack article. And I'm like, that sounds like mine. So I'm like, wait, which Pam are we talking about, GPT? So I had to like tell it which Pam we're talking about.
Oh, that's funny. Good way to use it intelligently. Good job.
Yeah. I just use it as what I call it as a productivity enhancer, because I feel like these days we have to use some type of, I don't know if have to, but it just makes life easier sometimes. And sometimes it comes up with things that I might not have thought of. Yeah. And it's not always right. So that's something.
Sure that. You know what I use it for the most?
Tell me.
Is when I know what my intent is in an email, but I can't find words that mean what I mean. Like the words I would use, I'm afraid are going to come off as rude or too short or abrupt, or because it's like I'm in a hurry and I got the things, whatever. But I don't want to come off that way, so I'm like, help me say this nicely, and ChatGPT just like gives me a way to say what I mean.
Yes.
And that's brilliant, right? Like, I'm not trying to pull the wool over anybody's eyes. I'm trying to actually, this is what I mean, but I can't figure out. Anyway, so I think that's a brilliant use of it.
100%. And that's, one of the beauties of using AI is that it gives, you can actually like tell it, I want to sound this way, or I want to sound that way. And yeah, I've used it when I wanted to write letters to administrators or even just a follow-up sometimes. And I'm like, how can I say this so it sounds a little bit like more polished? Yeah.
Sure. Yep.
Which is kind of funny because both you and I have both completed a dissertation, and you have written several books. But it's just nice to have that. It's kind of like when I was talking to somebody recently, and they said it's kind of like having Aunt Susie in the kitchen and being like, "Hey, Aunt Susie, how can I say this differently?" But
yeah. It used to be my mom. My mom was your Aunt Susie and my mom. I was like, "Mom, help me say this," which is funny because she's from Switzerland and English is her second language. But maybe that's like she had to really think about what she said, and thanks, Mom, for being really good at that.
I love it. Awesome. And you have not yet been replaced. Don't worry.
That's right.
By AI. Gosh. Nope. All right. So let's get into it. Pam, I always like to start asking the guests that come here is, what is your math story? And particularly framing it in, what were the moments that shaped your beliefs about what it means to do and teach math?
Yeah, I appreciate that. So I was driving home, and I was thinking hard about a conversation that I had just had with my kids' teachers, and I was troubled. I was trying to figure out what I thought, because they said, "Hey, Pam, we're getting the message that we don't want to give kids math anxiety, so stop giving kids timed fact math tests." And they said, so we don't want to give kids math anxiety, so we stopped giving kids timed fact math tests. But now we're noticing kids don't know their facts anymore. Is that important? Well, as a high school math teacher, I was like, that's important. But just like Pam, you and everybody listening, we don't want to give kids math anxiety. So I was troubled, right? I was trying to figure out, like, how do we manage this? I drove home. I walked in my door. I smelled a double fudge chocolate Pop-Tart. That means my kid's home. And I was like, hey. He was in 4th or 5th grade. I don't really remember. But I remember thinking, do you know? Hey, there's your dog.
There
I remember
she is.
thinking, do you know your multiplication facts? But what I said was, I just picked one at random. I said, do you know your fives? I will never forget. That kid looked me straight in the eye and he said, no. Well, he's okay, but I'm panicking.
Of course.
Because, I'm a math teacher mom, right? And I'm like, thou shalt know thy fives. Like, this is important. And I'm ramping, and he can tell. And he's like, Mom, you don't have to know your fives if you know your tens. I said, what? He said, you don't have to know your fives if you know your tens. I was like, dude, I heard what you said. I don't know what you mean.
Yeah.
Give me an example. So he goes, okay, let's say that you don't know 9 times 5. Well, 9 times 10 is 90.
Yep.
And 5 is half of 10, so half of 90 is 45. And I was like, good heavens, that is 9 times 5. Does that work every time? He's like looking at me like, and I was like, give me another example. So he said, okay, how about 5 times 23?
Wow.
Bam. Not the example I'm thinking of.
No.
Like, I'm thinking about single-digit facts, and he's playing with a pattern, a relationship, a connection, that you could find 5 times anything. Like 5 times 23. Like 10 times 23 is 230.
Yeah.
And half of 230 is 115. And I did a little bit of, and I was like, it is. That. Now that I can think about it, it's kind of a proof without words. If you have 10 groups of things, and you cut it in half to get 5 groups, and it's just really based on the fact that 10 times is so nice in our base 10 number system. And then you do have to be able to half things. That's a thing. But then, mom, you don't have to know your fives if you know your tens. Pam, in that moment, I was really clear that my kid was using mental actions that were different than the mental actions in my high school students. Like, my high school students, for the most part, were compliant. I would give them a problem and work it out with 3 worked examples, and then they would memorize that and mimic me. When I said, show me your work, I think I actually meant show me my work. Mm-hmm. If you mimic me and goof a little bit, I'll give you partial credit for almost mimicking me well. What my kid was doing, like when I said, what are you talking about? He told me what he was thinking about. The mental actions he was using were different than the mental actions, let me be clear, I was using. Yeah. And so I dove into research. I read journal articles and research studies. I wanted to know, could we create intentionally what he was kind of doing on his own? Because you might think, oh, he had like frou-frou teaching. No, he had same old. For whatever reason, he could run into a low dose of the same patterns that all of us run into, I had run into. For whatever reason, he could kind of naturally put those together. I think we all have kind of natural talent or natural inclination. I got a basketball behind me. Like I was a basketball player. That was a thing. I had some natural talent there. Yeah. Or maybe just natural. Maybe I wasn't. Some people like, Pam, you weren't all that talented. Okay, all right. But I wanted to. Like I had some inclination to give it a go, to try. For whatever reason he did. But I wondered, could we create that intentionally? And Pam, when I dove into that research, I also dove into my kids' classrooms and I tried stuff. I literally went to my kids' elementary teachers and said, may I enrich your students? Which was code for, can I experiment on them?
Brilliant.
And I just, like everything I read about, I tried. Because of my background in higher math, I was able to sift through a lot of less helpful research. We can talk about that more if you want. And find there's a real mathing way to teach. Yeah. So that all came to me to be, math is figureoutable. And we can teach it that way. And that's my math story. I was good at what I now call fake mathing. And it lulled me into this sense of, ooh, I'm good. I became a high school math teacher. I thought I was the god of math. Well, really, I thought I had to be the god of memorizing all that stuff and being able to regurgitate it, or I didn't belong in that space. So in an effort to not have imposter syndrome, Like I knew all the rules and all the steps in the rules and when to do which problem. But man, if you had given me a non-traditional problem, something I hadn't seen before, well, didn't even have to be non-traditional, it just had to be something I hadn't seen before. You know what my strategy was to solve it?
Tell me.
I would wait till somebody showed me how to solve it. Like that was literally, I thought math meant you waited till somebody told you the way to do it, and then you memorized that and you mimicked it, and that was mathing, which is, painfully clear now why I was so bad at abstract algebra, where you had to prove all that stuff I didn't understand.
Yeah, right.
Yeah, and so now, math is figureoutable. There's my math story.
That's beautiful. Towards the end of your story, what brought my memory, a memory that I have, is when I was in graduate school, I had to take a class called problem solving. So it was a math class, and I was in, I was teaching 6th grade at the time. So I would come after teaching a full day to grad school, and I sat in this class, and most of the students who were in that class were math. They were in the 5-year program where they graduate with their master's degree. So they were math majors, aiming to become most of them high school teachers. So I did not, and I don't have a high school cert. I have a K-8 cert. Okay. And so I came into this class every day with such imposter syndrome, because I'm like, maybe not every day, but for sure the beginning of the semester, I was like, I've been working with fractions and ratios and stuff all day. I have not been in calculus classes. Exactly. And so I would come to class in the beginning of the semester and with this fear, and the professor would give us a problem. And the problem was always a non-routine problem that nobody in the class had ever seen before. And the first inclination for all of these students was to reach underneath their desk to the bin where it was holding their notebooks and their textbooks from their other math classes to look up how to do it. Well, I didn't have bin. I had my pocketbook or whatever. I don't even know if I had a laptop. This is many, many years ago. And I was always the one to get us started because I had nothing to start from. I had no distractions.
You had a lot to start from. What you didn't expect to know where to start. So you just dove in using what you know.
Exactly.
And may I just call that now? That's
Please. Very
mathematical behavior. What it isn't is mimicking behavior, which is what I had been super good at. It's mathematical behavior to say, let me even figure out what this question's asking. What do I know that could bring to bear to actually figure out what it's even asking? And usually that gives you an inroad to at least begin to start solving the problem. Just figuring out what it's actually asking, right?
Yes.
Yeah, that's brilliant. Yeah, what a great story.
Yeah, that was a pivotal moment for me because the other students were, and also the other piece is the emotions that were taking place. Like I had fear, but I feel like that my classmates had more fear because when they started to panic, when they could not find the solution or the formula or whatever they were looking for, the procedure, they couldn't find the algorithm in their textbooks or their notebooks. Then panic started to set in, whereas I had nothing to go on from that perspective. I just had what I was bringing to class, which is exactly what the point of the professor was trying to make.
Oh, that's brilliant.
It's brilliant.
Yeah, I'm so glad you had that experience. That's awesome.
Yeah, totally. All right, so let's talk about, I was just on a trip in Italy, and I was sitting on the pool deck.
Oh my gosh, I'm so jealous.
I know, it's amazing. It was a long time coming, but so I was sitting on the pool deck in the middle of the hot afternoon, and people are talking. We're bumping into a bunch of Americans, and this one woman strikes up a conversation with me, and then she said, well, what do you do for work? So I tell her that I'm a math ed consultant, and that I help teachers learn how to teach math, and I was a teacher for many years, as a math teacher. She said, well, let me tell you. And she launches into this whole story, which I will not, go into the details of her child's experience, her experience teaching math, and her husband pipes in. And the reason why I tell this story is because from anywhere I go in the world, whether it's the grocery store in my hometown or halfway across the world in Italy, people are fascinated with telling me about the trauma or the I'm not a math person, or, well, we're not math people, so that's why my child struggled. Like, why do you think, what's underneath that statement, do you think, that idea that I'm not a math person or I can't do math?
Yeah. I think there's a couple possibilities for everybody that I meet. So this is anecdotal research on my part, but I have had the same experience. Mm-hmm. So I try to dig a little bit to kind of get what's behind. Mm-hmm. And a colleague of mine, Tim Pope, used to ask this question, and I took it up. And I'm like, I love that question. He would say, if you don't mind, how do you think about 36 minus 19? That was his favorite.
That was his question.
It was his question, and now I've picked it up. Now on the airplane, I'll like, what do you do? And I'm like, well, yeah, so glad you asked. And then I'll say, how do you think about 36 minus 19? Now at that point, I get a few responses. So sometimes people will line up the numbers. Maybe they'll write them down, but maybe they'll do it in their heads. And I'll just kind of ask. And if they line up the numbers, I got to tell you, Pam, 95% of the time, when I say, what is your vocation? What do you do? They're teachers.
Oh my gosh.
That's fascinating. Like almost no one else lines them up and does the thing.
But the teachers line them up.
The teachers line them up and do the algorithm. Now, there is a small percentage of people that will just give up and they'll go, yeah, I was never good at math and I can't hold all that in my head and I don't have a pen right now.
Yes.
And so I'm not a math person. And I might say, well, like, what if you had to solve that problem? Or I'll keep going with those people. What if you had to solve it? And then often they'll say, well, then I had to come up with these tricks because I wasn't really good at math. And so, I might do something like 36 minus 20, but then I subtracted too much. So 36 minus 20 is 16. So really it's 17. Or they might say, well, 36 minus 19, I'll just do 36 minus 10, and that's 26. But I still have to subtract what did I say, 36 minus 17?
You said 36 minus 19.
19. Sorry.
I wrote it down. See, I couldn't hold it in my head.
So 36 minus 10 is 26. I still need to subtract 9, so I'll subtract 6 and then 3 more, and so then I'm at 17.
Yeah.
And I'll say, so that's a trick? And they're like, yeah, because I didn't understand that way. And I was like, so actually what you just did, those are the mental actions of a mathematician. Those are the kinds of things that mathematicians actually use to solve problems. Every once in a while someone will say, yeah, I like this trick that I came up with. Instead of thinking about 36 minus 19, I'll think about 37 minus 20. Yeah. Because I don't know why it works, but I just learned that if you just like shift the numbers a little bit, then it's kind of like keeping this and I'm like, you're mathing better than I was as a high school teacher.
Yes.
And I'm saying, you know what? I bet you weren't good at the fake mathing that was sort of given to you, but it seems like you're actually pretty good at real math. That's my response when people say, I'm not a math person. I'm like, you know what? Like, tell me kind of what you're thinking. And then I leave them with, yeah, I get you probably weren't good at that fake mathing that we're sort of handed. But I bet you're actually pretty good at real math. And it's amazing to have people kind of stand up a little taller. Mm-hmm. I got to tell you, though, I also have another response, 36 minus 19. I will have people that will go, well, I just, like everybody, I just think about the numbers. And then they'll do one of those strategies that I just said. Like everybody does that. And I'll kind of chuckle and I go, not everyone does that. And they'll say, well, of course they do. And then I'll say, what do you do? And they'll often say, either I'm a scientist or a engineer or somebody who kind of naturally is sort of mathed, kind of like my kid did. I would say in spite of being given algorithms to mimic, they could run into those low dose of patterns. But do you know who else is? It's anybody who does that kind of thing in their life. So carpenters or often nurses, firefighters, like people who have to do things often in their work, come up with, they call them tricks, but really they're using relationships to solve problems. Yes. But because it's not the sort of official, formal way that they were led to believe was real mathing, I guess I'm not a math person. And that's where I'm like, well, actually, the strategies you're using are fantastic. Now, there's that small group, like I said, that are kind of the engineers or whatever. What's interesting to me about them is often they will go, everyone does that. And I'll go, so no, actually, and that's not, I'm not trying to be ornery towards them. I think they think that the way they learned was the teacher showed them an algorithm.
Yes.
And that helped them learn all the rest of the stuff. I invite everybody to consider they kind of did all the rest of that stuff on their own. That algorithms don't actually help us build all those other relationships. They actually trap many, if not most of us into the thing you're talking about. I guess I'm not a math person because that doesn't make sense to me. Or it traps them into using less sophisticated reasoning than the problems are intended to be developing and using. And then now we don't have our brains built sophisticated enough to be able to do the next kind of reasoning. And so, eventually, nothing's making sense, and we can't, especially if we can't mimic stuff. And then we end up where we are with a whole lot of people thinking they're not math people, when in reality, they just weren't fake math people. They're actually probably pretty good real mathing people.
I love how you just framed all of that. And I'm writing down a couple notes as you're talking. And the words that I'm hearing, I heard earlier, the word compliance, right?
Yeah.
So, I think that when people say things like, I'm not the other piece is I want to point out is that whenever I ask people, what was your memory from social studies class? Right? They'll tell me all these memories about math class. Or this, what was your child's experience learning social studies? What about reading? Like gym class. And gym class, sometimes there's some trauma around that. But, there's really, it's so amazing how people feel this visceral feeling about math, right? And then they embody it and it becomes part of their identity and like who they are. But a lot of it, like what you're saying, I think comes down to like, if you can't comply, then you're not in the club, right?
Can't comply or won't. I think there's also a group of kids out there that are like, this is dumb. Like, why are you having me do this? It has nothing to do with my life. All these steps you're trying to get me to do. And I think many of them actually are using real relationships to solve problems. Yes. And so when we say, no, you have to show me the steps to do 100 minus 98. All the borrowing and carrying and whatever. Yes. And the kid's like, it's 2. The answer's 2. That I think I actually have a lot of respect for that group. My daughter's one of them. That would be like, really? Really you want me to do all that silliness when the answer's clearly 2.
Yes.
And the teacher's like, it is? Wait, I have to do all the work to, or then there's the sort of standard response that's like, no, you have to be able to do yes, you can see that the answer's 2 here, but you got to learn these steps because there'll be harder problems later that if you don't know the steps, then it won't work for those problems. And I'm just going to ask everybody to consider that that's not true with the algorithms. It is true that we need to build our brains to be able to think and reason more sophisticatedly so that we can then think and reason more sophisticatedly. But that's not what we were sold. What we were sold is we've got to get good at mimicking these steps of algorithms in order to then be able to mimic the steps of another algorithm. But I invite everybody to consider learning one algorithm actually doesn't help you with the next algorithm at all. No. But learning relationships and connections, which means you're using strategies, letting the numbers impact how you solve the problem, that's actually synergistic. You learn one strategy, that actually helps you learn the next strategy, which then builds on to learn the next strategy. It's my son, actually, the one that I mentioned earlier, is the one who gave me those words. He's like, an algorithm, you memorize one, it doesn't help you with the next algorithm. It's a different set of steps. You got to memorize a whole different set of steps. Yes. But a strategy where you've actually built relationships and you're using those to logic through a problem, that helps you do the next more sophisticated strategy. Like they're synergistic. They build on each other. It was brilliantly said.
Beautiful. And, this does not just help us in math class either, right? And that's the whole piece that I'm starting to see more and more is that that more sophisticated reasoning, when we give students the time and space to have that thinking. And as a teacher, sometimes this can be scary, right? Sometimes this can be very scary because especially when, like, I'm just going to put myself, suppose I'm a teacher who does not feel very comfortable with my own math identity. And then I have a student in my class who's solving it like your son. being like, oh my gosh, I didn't even think, right? I mean, I wonder, did he share that with your son, when you were talking about the multiplying by 5, did he share that with his teacher?
No, he was kind of a quiet kid
Yeah.
who just kind of did his own thing, and didn't want to cause waves. Now, that was not true of my daughter. She would be the one that would be like, wait, that thing you just showed us, I don't understand it. And the teacher was like, you don't need to understand it, just do it. And she's like, whoa, I'm not gonna be, I can't memorize in fact, she told we do a challenge 3 times a year, just a free, my camera just isn't, if you can give me a second to fix that.
Yeah, you're good.
Wow, hope you can.
Yeah, no, I can still see you.
Yeah, but isn't it blurry?
It's a little blurry, yeah.
Yeah, just a second. Sorry. Lovely camera.
No, it's fine.
There we go.
Oh, there we go.
Yeah.
Better.
Okay, what was I saying?
You were saying
your
daughter wasn't gonna put up with the just do it this way.
So we hold a challenge 3 times a year, I often have a special guest. And one time, I had my kids as special guests.
Oh, I love that!
And I really didn't know what they were going to say, and especially my daughter's a little bit of a wild card. And she said, "Teachers, you might find this interesting." I was like, "She's just like, here she goes." I think she was like 19 at the time. She's at university, and she's like, "You might find this interesting. When you give me that series of steps to memorize, that to me is like looking at an ink blot." It's like you're saying, here is this Rorschach, personality test. Here's this ink blot, and I just want you to memorize the ink blot. She's like, I can memorize your ink blot. I can do it. But then tomorrow, you change the ink blot, and you give me another ink blot. Y'all, over time, those ink blots, they're just all a bunch of ink blots. She said, but if I can understand what's going on, I can do your stuff. But I want to understand it. I don't want to memorize your ink blots. Memorizing ink blots, I can do the math when I can understand it. Pam, I thought that was such a good analogy.
That's beautiful.
There is a segment of kids out there that, don't give me that. Like, help me understand, and then I can absolutely math with the best of them. And I think that's true for all kids. I'll just say boldly, everyone can do more real math than they can fake math.
I 100% agree with you. I 100% agree. And I feel like this thread is common as you're telling the stories through of the people you meet on airplanes and the 36 minus 19. And I think like people like you and me are trying to show the world that I have this shirt on and it says math is tough, but so are you. Oh, and nice. It's like, we're not trying to make math easier. We're trying to help you like develop these mental schema. So, but that mental schema has to be built on, I don't know if I'm even using the right word, but it's got to be built on what the child or the human brings to the table.
We have to start where the kid is.
Yes.
What do you know, and how can we build on that? Absolutely.
Yes. I do this one activity when I work with teachers. I say, if you didn't know it, nobody knows 8 times 7. So I shouldn't say nobody knows, but 8 times 7 is one of those ones.
It's an often missed fact. If you're going to miss one, it's often that one.
Yes.
Yep.
And I say, well, if you didn't know 8 times 7, what would you do to get there? And then it opens it up. And then it brings it away from compliance of just memorizing and knowing it's 56 to, there's lots of different ways to get 8 times, to put the product of 8 times 7. Let me show you how. And then the conversation becomes loud and open instead of just the answer is 56. Let's move on.
Well, if I may, I'm going to give you another often missed fact. So 8 times 9. Mm-hmm. The 8s, 9s, 7s, right? So there's, if I can help a kid think about 9 times 8, 9 8s as 10 8s.
Okay.
I need 9 8s, but hey, I know 10 8s. If I can think about 10 8s as 80, but I only need 9 8s, then I need one less 8 than 80. Now I can think about 80 minus 8, that's 72. Somebody might say, oh my gosh, you're going to bog kids down. But hang on. If I can have kids travel the path of thinking about 9 8s that way, then when they run into 9 7s, they could say, well, I know 10 7s is 70. I got to get rid of a 7. Hey, that's 63. But not only can they get the single digit facts that way, but now I could think about 9 27s.
Yes.
I could say, well, I know 10 27s is 270. But if I only need 9 of them, then I got to subtract 270 270 minus 27.
Yes.
But I can think about 99 sevens.
Yes.
I can think about 100 sevens and just get rid of ones. Now I have a strategy that if I'm thinking about 39 27s, well, maybe I can find 40 27s. Now I have to think about how to do that. But then I can subtract one. That's building multiplicative reasoning. Like
100%.
now I've got kids actually thinking about what it means to multiply, not just a bunch of single-digit multiplications, which I could be doing using skip counting, which is additive thinking, and I could be getting those answers correct using additive thinking, not even multiplicative thinking at all. Now I've got kids really building their brain so that when they hit a problem,
Yes.
and they're like, this is asking me for 98, give me something else, like 98 65s.
Yeah.
Then I might say, well, I can think about 100 65s.
Yes.
Now I'm in the ballpark.
Yes.
And even if I don't ever subtract those two 65s, I'm PDC. Pretty darn close.
I love PDC.
And it's not
way better than IDK.
There you go, PDC. No, pretty darn close. And it's not just a new way of estimating. It's not this sort of separate, hey, everybody, we need to learn to estimate. It's literally, can I be in the ballpark and then keep going? Like I can keep going. But now I have this general relationship that I can multiply by a bit too much and take off the extra.
Yeah.
I'm suggesting to the math education world that there is a small set of major strategies built on a small set of major relationships that if we focus on developing those in kids' brains, then they are actually doing the mental actions of mathematicians. One of those major strategies in that small set is the over strategy. And we just did it a few times.
Yeah.
Like we did a bit too much and then take off the extra. So 9 times anything, I can use an over strategy. But so can 8 times anything. Take off 2 of them. 98 times anything. 49 times anything. Find 50 of them and get rid of a little. There's just a small set of major strategies. Oh, the over strategy is one of them. And Pam, I can't tell you, I had never done the over strategy.
No, because you were lining things up.
As a high school math teacher, that was not in my repertoire until I met Kim Montague, who's my co-host on my podcast, the Math is Figureoutable podcast.
Yep.
And I was at, how do you do that? I was like, you do that all the time. She's like, that's like a thing. And I'm a little embarrassed to say how long it took me to realize that's a major relationship for all the operations. I can add too much and take off the extra. I can subtract too much. Remember 36 minus 19?
Yep.
36 minus 20, and then I can adjust.
Yes.
I can multiply by too much and then adjust. I can even solve proportions by scaling in tandem to too much and then getting rid of the extra. I can think about radian measure equivalents, like 2 pi. I know I'm getting into higher math. But I can think about like angles and how they relate to radian measure, and to find the 7/4 of pi. Like what is I can think about 1/4 of pi and 8/4 of pi. That's all the way around. That's 360 degrees. And I just get rid of just 45 degrees. And now I'm just thinking like that's a little over. So the over strategy is everywhere in mathematics. It helps us think about number relationships and magnitude and size and place value. And now my brain is grappling with those place values, not just using them mindlessly in an algorithm. Yeah, anyway, there you go. My camera did it again. Pam, I hope you can forgive my camera because it hates me.
I forgive your camera. Hey, this is all the process. It's totally fine.
All right, we're better.
That's fine. Oh, good. No, I think, well, when you started talking about the radians and stuff, and that, like, literally my mind went like, oh no, here she goes into high school math. But I have to, but then I have to remind myself, it's, I go to a yoga class, and the yoga teacher will say, get into such and such pose where you're like balancing, and she goes, don't make it a big deal. And I love when she says that, like, don't make it a big deal. So I just said that to myself, like, don't make it a big deal. This is just math, right? And I just think, everything you've shared today, what it really does is it puts the students in the place of it gives the students the opportunity to have the sophisticated reasoning, and puts them in the place of, like, authority is not the word, authority is the word that's coming to my mind, but
agency?
Thank you.
Agency to act.
Yes.
They don't have to wait till somebody gives them something.
Yes.
Use what they know, and with their agency, they can be like, I'm going to try this relationship. This one. That. Ooh, actually, like, and those are the actions, the mental actions of a mathematician. Those are the kinds of things that mathematicians do.
Yes, exactly.
Yeah.
Exactly.
Nicely said.
Awesome. So how do we get teachers on board with this? How do we get more teachers? Because I know we do have a lot of teachers.
I feel so strongly that the way that we can help teachers is we need to have more common experiences.
Yes.
One of the reasons that I just talked about the over strategy was you and I could talk about, we need to have this happen, but if we don't ever have actual math examples, then it's all words that mean too many different things to too many different people.
Yes.
So when I work with teachers, 99% of the time, the very first thing I do with them is math. Like we do usually a problem string, a series of problems intended to create relationships in the learner's head so they can use them to solve problems. And it's exactly what you said earlier, where we start with what the student knows, what the person knows.
Yes.
Teachers will often say to me, yeah, but that worked for us. That won't work for our kids. And I was like, I chose a problem string that I knew would work for adults. So what problem? Now, you need to know, here's Kim, my co-host, will say, know your content, know your kids. You need to know your kids, where they are, enough to give them a question, a starting question that they have access to. Everybody has some access to that question. Then that's a good problem string. And then can everybody build from there to learn more? And so our task is to know the content and know our kids. Let me actually, I'll give you a secret. When I work with adults, often my first problem string, my first mathing experience, so we all can have common vocabulary, is a 4th grade problem string. Like 4th grade, if I'm really, because that's kind of where many of us sort of hit the wall where we couldn't do it on our own anymore. And so then a lot of us just kind of gave in and was like, that sounds, I don't mean that pejorative. I mean, up to that point, many of us were kind of doing things and noticing relationships. Not all of us, many of us got stopped way before that. But a lot of people can kind of get to about 4th grade, but then by then the algorithms get so complicated.
Well, that's the thing. I think in 4th grade...
Long division is not very figureoutable.
No, it is not.
Especially the way we teach it. Yeah.
No, totally. Yeah. And I just want to interject with like a quick story about my own daughter at 4th grade. Her teacher was teaching the area model for multiplication.
Okay.
She taught it one day. Maybe they practiced the second day. The third day they were into the standard algorithm or traditional algorithm
you're
welcome, for multiplication.
Uh-huh.
And my daughter came home and she had been doing great with the area model. And now she's like, but my teacher says we have to do it this way because when we get to middle school, that's what they expect. And I'm like, okay, but you're 9 years old or 10 or however old she was and it's okay for you. But of course she's not listening to me because of what the teacher says I have to.
Yeah.
Right. So then back into the compliance, because my daughter is not a compliant. She's kind of like your daughter, wild card, never know what's going to happen. When she got to algebra 2 and started multiplying, maybe it was even algebra 1, multiplying binomials.
Yeah.
She was like, Mom, this is exactly what we did in 4th grade. And I was pretty good, but I tried to keep my cool with interjecting my expertise, or not expertise, but there was. Anyway, we'll just not go there. But the point is, I did try to nudge the teacher in the direction of but the answer to me was, but it takes them too long. It takes them too long to draw the rectangles. So we have to move on. They have to know how to just multiply quickly. And so that's why the rush to the traditional algorithm. But my point of the story really is that when my daughter got several years later to high school and is looking at this and saying, this is visual, served me well, right? And when she was able to do it, holding more in her head. See, I think I heard you say on an interview recently, you talked about, it was Kathy Fosnow's quote. It was about holding something in your head. I don't know.
Oh yeah, mental math does not mean you do it all in your head. Mental math means you do it with your head. Yeah,
with Kathy your head.
Yeah.
Yes.
Yeah.
Yes. Yeah, and I thought that was great. So she definitely still had to write it down, but once she had it written and it was visual in front of her, she was like, "Oh, I know the answer is, x squared plus 3x plus 5 or whatever." It was easy.
Yeah. Yeah, Kim and I have been thinking a lot lately about, she kind of suggested, we all have a visceral experience, memory, of having to do 40 multiplication problems with the algorithm over and over and over and over. And if you didn't have, in that moment, if you didn't have the single digit facts at your fingertips, then you were bogged down, and it was torture. I mean, let's be clear. It was torture either way.
Yeah.
But, I say that. I didn't mind it. Like,
no,
because
I liked it. It was comfortable. It was it was a security blanket for me.
I knew exactly what to do. I got the right answer, like all that. But fun would not be the right word. Certainly not creative. There was no agency. There was no, But if we have that very visceral memory, then of course we want kids to have the single digit facts memorized, and of course we want them to do that algorithm quickly because they're going to have 40 problems, and that's the goal of math class. So what I want to push back on is that the goal of math class?
Yes.
Like, why do we teach math? And I'm here to suggest, do we want right answers? Yes. Do we want kids to be able to think multiplicatively? Yes. Do we need them to solve 40 2x3 multiplication problems? No. Mm-hmm. Could we solve 10 multiplication problems, but give them specific numbers? So we're doing things like 125 times things.
Yes.
Or 299 times 2 digits.
Purposeful.
So that now kids are looking at it and they're going, if it's 125 times 87, could I find 100 87s? And then a quarter of those 87s. Well, I don't know a quarter of 87s. Like 25 is a quarter. Yeah. But I do know a quarter of 80, and I know a quarter of 8, and then I can go a little over. Like, if I can get kids thinking, now that may sound like, anything goes. No. I'm thinking about, there's only a small set of major strategies that I want kids, when they think about 299 times something, I really want them thinking about 300 times that thing and getting just rid of just one of those things.
Yes.
If we help kids with develop those major relationships, now we have kids agency. They're letting their creativity come forth. Which of these strategies works better here for these numbers? One of those 10 problems we give them should work well for several of the strategies. When I did that 125 earlier, I wish I would have said another strategy that they could have chosen would be to double the 125.
Oh, yes.
To get to 250. And have whatever the other thing is. Double again to get to 500. Have it again. Double to get to 1,000. And now I have 1,000 times whatever half that number is. And even if these halves weren't brilliant, now I have 1,000 times some decimals.
Yes.
Okay.
Exactly. And then it's not
now
so scary.
Kids are doubling and they're having, and those are relationships that mathy people actually use. And we can develop those in kids. So they're mathing the way mathy people actually math.
I love it. Well, thank you. Okay. So we're going to wrap up, but I could talk to you all day. We're going to wrap up, and I have a couple questions that I'm going to wrap this conversation up with before we go on to where can people find you and all of that.
Okay.
All right. So the first question is, what is something happening in math education right now that gives you real hope?
I would say there's a couple of things. One thing is when I work with teachers, and we do that, remember I said the very first thing I do with them is we have a common mathing experience so that we actually can communicate. Most of the time, I can get those adults in the room to go, that was intriguing. I'm at least tentatively interested in what you have to offer. I'm at least if I can make that, if we can get that shift.
Yeah.
I think in education, often we have these pendulum shifts.
Yes.
And it's like, we have a new superintendent, we have a new principal. Okay, they're going to come in with the thing, and they're going to, and it's, we can get a little jaded, and we can be like, I'm just going to wait this out. It's not going to last. You know, and what I'm about is not a pendulum shift.
No.
I'm not a new textbook. I'm not a new, this is mathematics. This is the way that mathy people actually math. When I can get people to go, I am tentatively interested in that. I'm willing to. Then bam, we have hope to actually move the needle, to get people to go. We can actually help students learn to math the way mathy people math. That probably gives me the most hope. I'll say that.
I love it. Okay, and then in one or two words, what's one piece of advice you could offer math teachers today? or 3 words.
Or who?
Or Sorry, 3 words. 1, 2, or 3 words. I don't want to limit you because you have so much great things to say.
2 or 3 words. Dive in.
Beautiful.
I have to, if it's only a few words. My few words of encouragement to math teachers today is to dive in to what does it mean to math, the way mathy people math. Ask yourself, how do I math? And I think there's at least 2, if not 3 responses. If your response is, Pam, I do everything you just said, everyone knows those things. I know you're out there. If that's you, I invite you to consider there's a way to teach intentionally what you did kind of on your own.
Yeah.
And then we can get everybody into the club. If you're the one who goes, I've never mathed that way, can I? I invite you to dive in to math that way, and now you can then teach kids to math that way. There's my short, not so short.
Awesome.
Advice.
Nope, great. That's great. And then lastly, how can listeners connect with you? Because I know you have these online mathing experiences too. So I think that's a great segue to that, and then anything else you want to share.
Yeah, I appreciate that. So when I suggest, and I think I'm one of very few people out there right now who is suggesting there's only a small set of major if it's not about algorithms.
Yeah.
Like almost everybody, even really good people who are, we should develop conceptual understanding. It's always so that kids can get better at the algorithms. Not that. I think I'm one of the very few people who is suggesting, no, there's a small set of major relationships we need to develop in kids so that then they are using a small set of major strategies. It's not anything goes. Yes. That there really is this, it's not one algorithm, it's a small set of major things. If anybody's interested to know what I'm claiming are those major numeracy strategies, then I have a free ebook that I would love to let your podcast listeners, viewers download.
Awesome.
You can get it at www.mathisfigureoutable.com/big, B-I-G, because I think this is big.
I love.
So I made it big because it's an ebook you can download that we created here at Math is Figureoutable to say to the world, here's what we think they are. We think if we develop these strategies, kids are actually mathing the way mathy people math, at least with numeracy. So mathisfigureoutable.com/big.
Big. Awesome. And social media, where can people connect with you?
So mathisfigureoutable.com, you can find all the things there. That's probably the easiest way to find all the social media, but I'm definitely on Twitter, X, at PW Harris, Pam Harris _math at Instagram, LinkedIn, just Pam Harris Math. You can find me. Blue Sky, Pam. I think it's just Pam Harris with the blue sky stuff that comes after it. What have I forgotten?
That's okay. Whatever.
Too many. Yeah.
I'll throw it on the show notes.
Mathisfigureoutable.com is a great place to find me and a lot of stuff that we do. In fact, Pam, you can click on Learn Now at mathisfigureoutable.com, and we have a ton of free stuff that we put out just to help teachers. And that's my invitation. Yeah. Just dive in and start mathing. Oh, one more. Join me on Math Strat Chat. So,
yes.
# Math Strat Chat. Every Wednesday evening in the States here, I throw out a math problem and people from around the world put in their strategies and comment on each other's thinking. It's super cool. It's a great way to kind of join the Math is Figureoutable community. Also, you can find Math Strat Chat on Facebook. We have a Math is Figureoutable teacher Facebook group that is vibrant. We actually curate stuff that happens in there, so it's not anything goes. We kind of monitor things to make sure that it's math being figureoutable, not people selling stuff or not a bunch of ways, not new ways to memorize and mimic.
Beautiful.
It's all about math being figureoutable.
I love it.
Bam.
Thank you for your time, Pam².
Woo!
This is a great Pam². Great conversation today. Thank you so much, and I hope to see you in person someday.
Thanks,
again.
Pam. It was fantastic. Appreciate it.
So great. Take care.
I'm Pam². Thank you so much for joining me on this episode of Blue Glasses Math. Please follow me wherever you get your podcasts and follow along on the conversation on Instagram. And remember, being a math person is all just a matter of perspective.